Lesson 77, solving two-step and multi-step inequalities. I'm just going to teach this by showing you four examples. So for example 1, we have 5p plus 8 is greater than or equal to negative 32. We solve this just like we do if there were an equal sign. Here, we're going to subtract 8 from both sides and we get 5p is greater than or equal to negative 40. Then we're going to divide by a 5 and we get p is greater than or equal to negative 8. So when we draw that on a number line, we're going to have our numbers negative 9, negative 8, negative 7, negative 6. We're going to put a closed circle on negative 8 because it includes, with that or equal to, it includes negative 8. We pick a number that would fit here. If I put a negative 9 right there, that's not going to work because that's less than negative 8. So if we put 0 there, that would work. So we're going to draw our arrow toward where 0 is. Colored in nice and dark to show that it's going to the right. Example number 2, we have negative 24 minus 3x is less than 15. So we solve just like if it was an equal sign. We're going to add 24 to both sides. And we get negative 3x is less than 39. Now when we divide by a negative number, we need to flip our sign to a greater than sign. So we have x is greater than negative 13. So we're going to have our number line, negative 14, negative 13, negative 12, open circle on negative 13, and then we want to shade numbers that are greater than negative 13. So it goes to the right, make our arrow very noticeable. Example 3, if we have 4 parentheses x minus 3 is less than or equal to 6 squared. So I'm going to start by using the distributive property and squaring my 6. So I have 4x minus 12 is less than or equal to 36. I'm going to add 12 to both sides, and I get 4x is less than or equal to 48. Then I'm going to divide by 4, and I have x is less than or equal to 12. Then we're going to draw our number line, and we have 11, 12, 13. Close circle on 12 because it's or equal to, which means it's included. We need to pick numbers that would fit into the statement. And since we're looking for numbers smaller than 12, we're going to go to the left and make a giant arrow going to the left. Okay, one more example. Example 4. Why do I keep putting these colons in here? That doesn't go there. There we go, fix that up. Example 4. I have 5/8 times p minus 1/3 is greater than or equal to 11/12. So I'm going to add 1/3, but I want to write it with a denominator of 12. 3 times 4 is 12, 1 times 4 is 4. So we have 5/8 p has to be greater than or equal to 15/12. Then to do inverse operation, I need to multiply by the reciprocal of 5/8 greater than or equal to 15/12 times 8/5. Let's see, 4 goes into 8 twice, and into 12 3 times. 5 goes into 15 3 times, and we can cancel 3 divided by 3 is just 1. So this goes to 1. We have p is greater than or equal to 1 times 2 is 2 divided by 1 is just 2. And if we wanted to graph that, we'd put 1, 2, 3, close circle on 2, and we want to find numbers that are bigger than 2. So that's to the right. That's the end of the lesson.